Okay, so interval notation, say we have here AB from A inclusive or exclusive up to B exclusive. We can rewrite it as a set of all x such that x is greater than A but less than B. We can, or in graph, we have this. A is hollow and B is hollow. And the solution is anything, any number in between A and B, but not including A and B. Now, here we use bracket. Okay? Since we use bracket, it tells us that it is from A inclusive, A is inclusive, up to B inclusive. Meaning to say, A and B are part of the solution or part of the graph. It is the set of all x such that x is greater than or equal to A but less than or equal to B. And as you can see, A and B are shaded because A and B are part of the solution. Now, for the third one, we have A inclusive but or up to B exclusive. A inclusive up to B exclusive. Meaning to say A is a part of the solution but B is not. So we have here the set of all x such that x is greater than or equal to A but less than B. So as you can see here, A is shaded but B is not because A is a part of the solution but B is not a part of the solution. Okay? The opposite of that is this. A exclusive up to B inclusive. Okay? A is not part, but B is a part of the solution. So we have your set of all x such that x is greater than A, but less than or equal to B. And B is a part of the solution, that is why it is shaded. A is not a part of the solution, that is why it is not shaded. Another interval notations are from A in exclusive up to positive infinity. Take note that we cannot bound positive infinity, so we cannot include it, no? That is why we always use parentheses. And that will be, it is the set of all x such that x is greater than A. And if we're going to draw it, we have only A here and then to the right. Anything greater than A is part of the solution. What is the difference between this one and this one? The only difference is here A is a part of the solution. That is why here we have shade. And this one has an equal symbol. It is less than or equal symbol. A is less than or equal to x. Okay? For the third one, we have negative infinity up to B exclusive. So we have here set of all x such that x is less than B. Take note that since we do not have equal sign on below the less than symbol, letter B or the point B is not included. Okay? It is not shaded. Okay? And for the fourth one, we have here negative infinity up to B inclusive. Since B is inclusive, as you can see, there is an equal symbol below the less than symbol. So it means B is part of the solution, hence it is shaded. And if we are given negative infinity up to infinity, it tells us that it is the set of all real numbers. It is another way of writing the set of all real numbers. By the way, this is the third part of our, or fourth part rather, of our discussion in rational function. Rational inequality is a mathematical statement that relates a rational expression as either less than or greater than another. Take note that the zeros of the numerator and the denominator are called the critical numbers of this rational inequality. Okay, how to solve a rational inequalities? Actually, I really do not want to read, but for the purpose of this video, let me read the first step. Rewrite the inequality as a single fraction on one side of the inequality symbol and 0 on the other side. So we must isolate uh, 0, no? As much as possible. Make the denominator and the numerator and the denominator in factored form. Second one is to plot the critical points on a number line. How are we going to determine the critical points? The zeros of the numerator will not be included in the solution. It is not shaded. Okay? The zeros of the numerator will not be included or not shaded in the solution if there is no equal sign below the inequality symbol. This is what I'm referring a while ago. Otherwise, the zeros of the numerator will be included in the solution or it will be shaded. So identify the intervals made by plotting the critical numbers. Okay? Choose a test value in each interval and construct a table. The sign of the rational expression at this point is also the sign of the rational expression at each interior point in the aforementioned interval. Fourth one is to use the table to determine which intervals satisfy the inequality. If the inequality is of the form f of x is less than 0 or f of x is less than or equal to 0, then all intervals with the negative sign are solution because, as Itab said, it is less than 0. But if the inequality is of the form f of x is greater than 0 or f of x is greater than or equal to 0, then all intervals with the positive sign are solution because any number which is greater than 0 are positive. So for next one, we have the example. Let us try to solve and apply what we have seen on the steps. Okay, let us follow the steps. How are we going to solve for this? Step 1. Isolate the 0 or make it, or let us put all rational expression on the same side. I just transpose or I just use the addition property of inequality here. So subtract both sides by 3 over x plus 1. After doing so, let us make it a single rational expression by multiplying the terms by their LCD. Or in other words, we can also make this as we're going to multiply negative 5 by x plus 1 and 3 by x minus 4. Cross multiplication, perhaps. And then we have this. Okay, x plus 1 was multiplied to negative 5. X minus 4 was multiplied to negative 3 or 3. And then we can add or we can combine the two terms or the two rational expressions since meron na silang or they have the same denominator if we do this. Now, what's next? Let us simplify negative 5 multiplied by x plus 1 and negative 3 multiplied by x minus 4. If we do so, we have negative 5x minus 5 by distributive property and negative 3x plus 12. Negative multiplied by negative, it will be positive. 3 times 4, 12. So, simplify. So, if we simplify negative 5x minus 3x or combining similar terms, we have here negative 8x. And negative 5 plus 12 will give us 7. So, we have negative 8 plus 7. All over x minus 4 multiplied by x plus 1. Now, these rational expression, the numerator and the denominator of this is already in factored form. Now, the critical numbers are the zeros of the numerator and the denominator. Hence, we must equate the numerator first by 0. Okay, solving for x, we transpose the 7 to the right, so it will be negative 7, and then dividing both sides by negative 8 will give us x equals 7 over 8. So the first critical number is 7 over 8. For the denominator, we have x minus 4. Let us equate the denominator to 0. X minus 4 multiplied by x plus 1. So, by the zero product property, x minus 4 equals 0 or x equals 4. That is the 0 or the critical number found in the denominator. And for the second one, we have x equals negative 1. Let us plot now the graph or this one. We have here, as you can see on the number line, I have here negative 1, 4, and 7 over 8. 7 over 8 is near 1. It is less than 1, so it is not exactly at 1. Okay? So, that will be the number. And these are the intervals that can be made with this number line and with these critical numbers. From negative infinity, here from negative infinity up to negative 1. So, that is the first interval. The second interval is from negative 1 up to 7 over 8. Take note that those are exclusive. That is why I am using parentheses. Okay, from 7 over 8 up to 4. So we have here 7 over 8 over 4. Fourth one or fourth interval is from 4 up to positive infinity. Since there are 3 critical numbers, there are 4 intervals. Okay? Test point. Now let us think of a number that is part of negative infinity to negative 1. And that can be negative 2. How about for the second one? In between negative 1 and 7 over 8, 0. For the third one, we have 7 over 8 to 4. We can have 1. Okay? And for the last one, from 4 to positive infinity, 5 can be a test point. Now, let us substitute negative 2 to x. Negative 2 multiplied by negative 8, negative times negative, positive. Okay, positive 16 plus 7, it will be 23. But what we want here is just the sign. So it will be plus or positive. How about for the second one here? 0 multiplied by negative 8, 0 plus 7, 7, a positive number. How about for 1? 1 times negative 8 plus 7, negative 1, negative 5. Multiplied by negative 8, negative 40, plus 7, still negative. Here we have negative 2 minus 4, negative 6, negative 0, minus 4, negative 4, negative 1, minus 4, negative 3, negative 5, minus 4, 1, positive, negative 2, plus 1, negative, 0, plus 1, positive. This one is 1, plus 1, 2, positive, and 5, plus 1, positive. How about for f of x? What do you mean by f of x? If you're going to recall, okay, negative 8x plus 7 is or will be divided by x minus 4 multiplied by x plus 1. Or in other words, we must just multiply the sign of this. Okay, that is what we are going to do. Multiply the sign. Negative multiplied by positive, negative, negative multiplied by negative, that will be positive. Next, positive multiplied by negative, negative, negative multiplied by positive, negative. So that will be negative. Negative multiplied by negative, positive, positive multiplied by positive, positive. And lastly, negative multiplied by positive, negative, negative multiplied by positive, negative. So this one is negative. So we have here the summary of what we have in our sign table. F of x has the sign positive in the interval negative infinity to negative 1. From negative 1 to 7 over 8, both exclusive, negative. From 7 over 8 to 4, exclusive, positive. And for 4, exclusive up to infinity, negative. Since we all know that negative 8x plus 7 all over x minus 4 multiplied by x plus 1 is less than 0. It is of the form f of x is less than 0. All intervals with negative sign will be the solution because it must satisfy the inequality. Therefore, as we can see here, the interval with negative sign are from negative 1 exclusive up to 7 over 8 exclusive, union, because we are going to combine these two, 4 over 8 or 4 up to positive infinity. So we have here 4 up to positive infinity. If we're going to graph it, okay, it will look like this. From negative 1 exclusive, negative 1 is not included, up to 7 over 8 exclusive. 7 over 8 is also not included. Now we have here 4 exclusive up to positive infinity. So that will be the graph of the rational inequality. Now, or the solution of the rational inequality. Now, if you have any question, feel free to message it on the comment section or send a private message or PM to my Facebook page. Have a nice day ahead. Thank you for listening. Don't forget to subscribe, hit the notification bell, and click the like button so that you will be updated to our next video.